All right. Oh, yeah. Hello, everyone. Thanks for joining tonight. This is a little talk I've had in mind for a while. It's been a while since I've seen some discussion on WebSockets. I've used it quite. I've been using WebSockets quite frequently in various projects recently. So, figure this would be a good topic to review. If any of you worked with Elixir or any other system that uses WebSockets or any kind of pub sub. This is going to be more of a just a review on that. So it might be some repeat information here, um, but hopefully you all get something out of it. So the agenda for tonight, we're going to discuss broadly, I guess broadly, more specifically, what WebSockets are. We'll go over the pub sub model, publishers and subscribers. We'll look at Action Cable, which is the Rails package for doing pub sub. We'll talk about server-sent events. Server-sent events aren't WebSockets, but they've been there's been some recent discussion on them. I think there's been one or two JavaScript frameworks on them. So I thought that this is a good topic to include as well. Just compare the two. And then I'll have various demos of code throughout as well. So WebSockets, you think of WebSockets as a live connection between a web browser and a server. Typically, when you're using a web browser and you're going to websites, you're interacting with web apps, all that data is being transferred over HTTP. HTTP, it's a protocol on top of TCP. I didn't write much on TCP here, but TCP, to my recollection, is you have two applications. They could be on different networks. One application, the client sends a connection request to the other application, the server, and then that server sends a acknowledgement, and then the client also re-acknowledges that it received the connection, and from that point on, data can be transferred back and forth between client and server. So with HTTP, HTTP defines a specific payload structure for data being sent after that connection is made. So you think of your standard HTTP methods: get, post, put, content, or no, yeah, headers, like your content type, your accept, your body, your query parameters, all that makes up an HTTP payload. And so when you have an HTTP connection, the client sends a payload, the server sends back a response, and once that's done, one or both parties will close that connection because that connection is considered complete. We're no longer using it. But with WebSockets, it's more lower level, closer to plain TCP. The client will initiate a connection, the server will acknowledge it, and then the socket is just open. Client and server can send and receive messages. And in the context of web apps, this is often used for features that require real-time feedback. So chat features are common, notifications are common. I've even seen it used for like small games. Nothing usually too graphic intense, but things where you require like multiple users live in a session at the same time. Those will typically use WebSockets. And here I put together a couple of graphs showing HTTP and WebSockets. So for HTTP, you have a client, you have a server. The client will send a request to the server. The server will respond with payload, and then once that's done, the connection is closed. But with WebSockets, the client will make an initial request, and that will actually, in most contexts, over with a web browser, that's going to be over HTTP. We'll look at an example later in Node where none of it's happening over HTTP, but in a web browser, the client will send a request to like a WebSocket address, and the server will actually respond with an HTTP response, but it will be for it'll be a status code of 101, I believe, and that's will indicate that it's switching protocols. And then that connection will remain open. There'll be like a handshake response, and then the connection is left open. So both the client and the server can send and receive messages at that point. And so WebSockets are usually paired with the publisher and subscriber pattern, the pub sub. When clients connect to a server, they're going to be expecting to receive messages from the server, and depending on the use case, the client might not want to receive everything from the server. I want to filter some things out, so it's common for clients to subscribe to specific server events, and that's why this is a subscription. It's usually the client initiating a subscription, and then when a client subscribes to something, the server often takes inventory of who is subscribed to what. Don't necessarily have to, but that's common practice, I think. And then when an event occurs, the server will create a message and publish it to usually some kind of channel abstraction that represents the subscription, and then from there it will distribute the message to all connected clients. It can actually just send a message out to everybody, and then only the clients will filter it out, but it's also common for the server to try to filter it out to specifically who is subscribed. So this is your publishing. It's often also called broadcasting. We'll come back to Action Cable later. Any questions on WebSockets so far? All right. I'm going to switch screens. I'm going to show, let's see. Do this. All right. So put together in Node.js a simple WebSocket ping pong app. So let me see what I want to show first. So we have index.js. So this is like an Express.js web server, but it's set up with this WebSocket client, and then creates a WebSocket server. And when it receives a connection, it sets up a message handler, and then when it receives any message, it will just respond back with the word pong. Then I also have a client file, which I don't actually, this doesn't run by itself, but these are things I can copy into a Node session. So the way this is used is I'll run node index.js, and that's like our running server. And then if I just start a node console here, I'll just copy these things over directly. So we'll create a WebSocket. Oh, I pasted, there we go. I'll create a WebSocket object. And then we'll start listening on port 3000. And that port 3000 is just what the Express server is listening on. And then we'll actually set up a message handler of our own, because remember, both the client and the server can receive messages. And so we'll want, if the server sends us something, we want to be able to just print that out to the log. But as a client, I can start sending messages. So if I send a ping, um, up here on the server, it printed the word ping. That's the payload that it received. And then on the client, we printed pong because that's the response that we got. And so messages went through both the server's message handler and the client's message handler. And that's just an example of a very low level in JavaScript how to use WebSockets, and to show that both the client and the server can send or receive messages, and you can send multiple messages. It's not restricted like HTTP. Um, that socket is still open, and I can send whatever I want. I think any kind of binary data too. I think so. I tried this yesterday. I don't think everything prints out correctly. Like arrays don't uh, print, but they are being received. So that's a simple example. Um, for a more fun example, uh, I created a small chat application where the client is a React app and the server is a Node Express app. And so if I think here I can do get node index.js, start the server, and then npm run start the React app. And I'm going to switch screens again. Resume. Okay. I give myself space. Just zooms a little bit in the way. I probably just pull this down here. Nope. All right. So here we have a chat application, and right now there's a channels list, and then there's a new channel option. So we'll go to new channel, and we'll call this RubyJax. Enter your name, and here we're presented with a chat window. I can do hello, and that prints out my message. Now, if I open a new tab, go to localhost 3000, go to channels, we see we have a channel with an ID, a name, and the number of users. If I click join, we'll say I'm Bob. And so now I can send messages as well. And if I go back to the first tab, we see that Bob's message has sent as well. And so if I respond again, that message comes through on the other tab. So this shows that I can have multiple multiple users on the same socket listening. I don't have to refresh. I don't have to initiate any other requests. And to show a little bit what's happening in the background, I'm going to open up console tools. I think it'll show up. And if I go to network, I'm actually going to refresh this, I think, so I can see the connection made. So when I connected, we made like a WebSocket request at 3000. There's two of them here. Forget what this is about, but this is the one that's being made in JavaScript to our backend server. So You see here we've made a HTTP GET request to WS localhost 3001. That responded with a 101 status saying that it's switching protocols, and basically means that the HTTP part is done. The connection is still open, but we're no longer expecting to receive an HTTP response. If we go to the response tab, instead of seeing like a traditional payload response, we have a list of data. And the first, so the green arrows represent data that the browser is sending, the down arrows, or the down right arrows represent data received from the server. So when I connected, I sent, let me see if I can, yes, that's data, yeah. When I connected, I sent a subscribe message to the backend and saying that I think this is the channel ID and this is the channel name that I'm subscribing to. And then it sent back a confirmation that I have in fact subscribed. Now, if I go back to the second tab and I send another message, what's going to happen back here is we'll get another WebSocket response, and that is our this is ultimately becomes our the message that we append to the chat. So this is all data I've configured. I say the request type is chat message. There's a channel ID, and then I think this is just a message ID. But then yeah, the sender name and then the actual message. So I'll show you a little bit of the code now. Let's see. Yeah. So on the client side, most everything is happening. I'm trying to remember where I put everything. Yeah. So on the channel list page, this is where it was. No, the channel new. Right. So when you whenever you click new channel, it brings you basically to a blank component, and then it prompts you to enter a new channel name, and then it will navigate you to that channel. So in that, it also generates the channel ID. And so if I go to channel show, in our use effect, which is basically our initializer, it prompts you for the name, and then it sets the channel name if there is none, and then here's where we're actually setting up the WebSocket connection. So back in the node example, we had to use a WS package, but since we're in the browser here, we get this WebSocket class with the browser, so we can just instantiate a new WebSocket object like so. And then here we just set up our event handlers. So when the connection is open, we can handle that event. And in this case, we're just sending a subscribe message to the server. And then on the message handler, this is what when the server sends us messages, this is what we'll use. So we'll either get a chat message from another user, or we'll get a subscription confirmation. And in this case, I'm just making sure that the channel name is set. And then most everything else here is just, most everything else is just page stuff, except for this. So when I send a message, I'm constructing the body of the message to send to the backend, and then adding it to my own messages, but then I'm also sending it via the socket to to the back end, which will then propagate that to other users. So that's a low level example of pub sub. Any questions so far?
So
Ship it. Oh, sorry.
you say
Yeah.
ship it.
Yeah.
So the messages, or in this example, the messages are just in memory. So like if
Yes.
somewhere to happen, you can't come back to that point.
Um, correct. Yeah, especially this is the front end side, so
Mm.
we're just getting the messages as they come in.
Mhm.
I could have like a back end persisted thing, but really it's just yeah, like if I come back to the front end of this or the browser, when I rejoin this channel, sorry, everything the screen is actually pretty small. When I refresh this, it doesn't have any of the, I can't type. It doesn't have any of the previous stuff in here.
Gotcha.
But I'm connected to the same channel and I'll receive messages, but yeah, I didn't bother setting up a database or anything like that.
And that was WebSockets.
Yes.
Okay. But I just saw Josh and Michael joined.
Yeah, I saw.
Ryan. Okay.
Yeah, so that was the client, and then on the server side, very similar thing here. So we set up a message handler, and then when we get a message, we're looking at the request type, and all I send was JSON. So there's no like protocol that's saying I have to have like request type or anything. I just send over a JSON, and then I'm looking for, in this case, a request type of either subscribe or chat message. And if it's subscribe, then there's a little bit going on here. But I have a local subscriptions object in place. And so I'm trying to find the subscription key or the subscription for this channel ID. And if that doesn't exist, then I'm creating a new one. And then from there, I'm getting the current subscribers. The subscribers are actually all the connected sockets. It's just an array of sockets. And then I'm adding my own socket to it. And then once that's done, I'm just sending back a message to confirm.
Wilder. Hola. Muy bien. ¿Y tú? Bien. Yes.
On the yeah, if I receive a chat message, then I'm iterating through all the subscribers that, and then just relaying the message I just received back to all the subscribers for that channel, except for myself. And let's see, was there anything here on close? Yeah, so we also have a close handler, which when a client disconnects, we can manage that event too. In this case, I'm just cleaning up the subscriptions channel, so I'm not rebroadcasting messages to clients that are no longer connected. Let's see. And the rest of this wasn't even WebSockets, it was just HTTP setup. So the WebSocket library in JavaScript is very succinct. You can set up all this with just 50 some lines of code. I find to be quite impressive. That's all for the JavaScript side. I'll talk a little bit about Action Cable.
I have something on the Elixir side if you have time
Sure.
with WebSockets.
Yeah, I'd love to see it. Let me see. let's get through some of the action cable stuff. So action cable, yeah, just like right off the bat, this is probably its own talk. But yeah, action cable is the Rails library, the Rails implementation for pub sub over WebSockets. They give you channel classes for managing events and publishers. They give you cable classes for managing connections. There's a variety of JavaScript functions for the front end to establish those connections, and then yeah, you use the channels to broadcast events. Yeah, sorry, doing a lot of jumping around. I wish Zoom had a way of just letting you switch screens. So I have a Rails server here, and it's complaining that I have this server on still, so we'll close that out. Okay. Actually, I should probably show you the front end of this first. So we'll do that. Now I show the localhost 3000. So we have a pizza delivery app. We won't be looking at pizza deliveries that much, but sign in. There we go. In this app, I have a users page where I can send messages. I also have a notifications bell, which shows me recent notifications. I'll clear that out. So the way this works is I click send message, type hello, and then we get the notification here. I could send it to other users too, but I just sent a message to myself. So if I send it to someone else, I'm not going to get that notification, but someone else will. We'll go ahead and clear that out. And similar to the other example, I can have like multiple tabs open, and both these tabs are clients, and they're listening for messages. So when I send another message to myself, I get the notification there, but I also get the notification on the other tab. So I can see it in both places. So on the front end of things, not too much different than the JavaScript app that I showed you. I'll show you the dev tools again, just to show that we are using WebSockets. Trying to get Zoom out of the way. Go on. So here we have an initial request to this cable path, WS localhost 3000/cable. It switches protocols, and then on the response, we see we get like an initial acknowledgement message, and then once that's done, the client sends up a subscription. So this is a command subscribe, and we're giving it the notification channel, which is the event that we want to subscribe to. And then the server acknowledges that subscription, and then it's just waiting. So we see a lot of these ping messages. So this is just Rails ensuring that we're still connected. So remember the last example, we were cleaning up subscription objects from ourselves. This is their way of doing it. They're constantly just pinging all of their clients, and if they don't get a response, then they'll probably clean something up on the back end. And so when I send another message, we'll see that come through. So here we have, saying this is for the notification channel, and then message is our object. So we'll take a look at the code now and show a little bit how this works. So we have a few things. We have a that notification bell that's in this nav header layout. So layout in Rails is like a component. And here we have not a lot going on here. We have a button. We have a stimulus click action that just shows the notification modal and then notification count. Initially, notification count, I believe it's an application layout application. So I just have like an initial query to hit my database for notifications. So in this case, we are storing everything in a database. So if I come back to it later and I've received notifications while I was offline, I will see those. But that's just the initial setup for that count. So in this case, the notification bell is it's visible on all pages, and so we want to be able to get updates when we're on any page in this application. So in Rails, we have an application JavaScript file where we import all the things we want, and in this case, we're importing a notification channel JavaScript file. So if I hop over to that, this is where we start getting into the meat of it. So consumer is it's a Rails provided action cable function thing. So I can use this to generate subscriptions. So in this case, I'm using consumer subscriptions. And I'm creating a subscription into the notification channel. And then from there, it takes care of everything, all the connection stuff. All I have to do is provide the handlers that I want. So in this case, I only care about when I receive data. So I have a receive data callback. And most of this code is just setting up the actual message. It's part like parsing times and stuff. But what I get back here is data ID, data message, and a data created at. So most of this maps totally to the notification object I have on the back end. So that's really all I have to set up on the front end. On the back end, you just create a class for the channel that you want, the event that you want to publish. And then this subscribed is just saying, the stream for user saying, I'm not going to broadcast messages to everyone subscribed on this channel. It's just going to be for the specific users, which so when you broadcast a message, you have to specify who it's going to as well. And that's done here in this case. So I have a notification channel broadcast to. I give it the user I want to broadcast to, as well as the notification object. If I wanted to send a message out to everyone listening on this channel, I would do notification channel. I believe it's broadcast 4, and then you just give it the notification. And if you did this, then the client would have to filter out the messages that pertain to itself. I think there was something else I was going to show. Oh yeah, I guess you're wondering how we get current user, application cable. Yeah, so it's just saying that the current user we're going to use is our authenticated user. That's a detail for another time, though. I think that's all I have on Action Cable. Any questions?
So is Action Cable just a wrapper around WebSockets?
It's a wrapper around WebSockets, and it's also a publisher subscriber setup. So the channels that I was showing, that was a custom channel, and you can create as many as you want. So when you want to send messages, you can specify what you're sending them for.
And so in the Rails console, do you like see those messages when they're occurring?
Like in the server logs, or
Yeah, just like if you're trying to figure out if it's
yeah,
working or not.
actually, here, we just were. So I'll share again. So,
I wasn't paying attention to the server logs.
yeah, no, that's I wasn't sharing them. I was just sharing the editor.
Okay.
So, like after this is my connection, but then here,
Okay.
the notification channel transmitting. We have like a few of these actually. So
I see him. Yep.
and you have like the ID, which is I think ID is there's its own like message ID. Oh no, this is the notification ID record because I was saving it to the database. And then you have your message, and then yeah, these are all just attributes that come from my active model object.
Gotcha. And then it's sending it to user ID 1, whoever that is.
Correct.
Okay.
Yeah, that's why I was able to. That's why I showed like um, me sending a message to someone else, because I wanted to show that it's not just receiving everything for that channel. Um, it's actually targeting specific users.
Mhm. All right. Cool.
Let me see here.
Surprised Michael doesn't have any questions.
I think Michael wants to share some Elixir.
Oh, okay. He's waiting.
Let's see. Yeah, this next part will be quick. I think most of the people in this call were there on the server sent events thing. Let me get back into the slideshow mode. So yeah, server sent events. So you might remember the last RubyJax a couple of months ago where we did lightning talks, and one of the things I demoed was an example of server sent events in Ruby. And that demo was very similar to the one I just showed with Action Cable. In fact, I think functionally it was identical. So you could use server sent events in the same way you use WebSockets for the most part, especially for that notification example. But I probably should have updated the slide. I said server sent events utilize HTTP. They do utilize HTTP, although um, once your connection is established, you can send stream messages in any format that you like. You don't have to send HTTP payloads. But the way it works is the client sends an HTTP request, and I think it has to be to either. No, it doesn't have to be a specific endpoint. It's you give it a content type. I think it's like text event stream, and when the server reads that, the server should interpret that as okay. Um, the client is wanting to receive multiple messages from this endpoint. So the server will send a 200 response, but the connection will remain open. And in fact, some browsers don't even interpret it the right way. So if you look at Firefox, it will show the 200 response, but it won't show anything after that. And it won't show that the connection is resolved. It'll act like the connection is hanging basically without resolving. Chrome does it a little bit better. It'll show the 200 response, but then it'll, similar to WebSockets, it will show all the messages that come in thereafter. So very similar. There's, I believe there's event. I forget the terminology now. I forget what the JavaScript functions are that set it up, but you set it up very, very similar to WebSockets. The only difference with server sent events is only the server can send messages. The client can't send messages over that socket. So it's a little more secure. The downside, which I'm not very knowledgeable on the why behind it, but in my test app setting it up, it seems to want to use more server threads than WebSockets. And so like if I do it in Rails, it will, if I do a Rails app with the Puma web server and in development, I say I have 5 threads. If I open 5 tabs in my application, and they're all calling out to server sent event endpoints, all the threads will be immediately used up. There's no good like thread management there. Where that's not a problem with WebSockets or with Action Cable anyway. So some more investigation there, but yeah, main difference with server sent events is little configuration with how you set it up, but also server sent events are one way, only the server can send messages out. Yeah, and here's just another diagram of how it works. So client sends a request, the server sends an initial response, but then the connection remains open and the server can send more messages out. And yeah, that's all I have. I'll share these slides to the meetup after, and then I'll also post the recording to YouTube. And yeah, I hope to do more talks on this subject. I honestly not too knowledgeable on the lower level workings of this, but as I said, it's been a while since I've seen anyone talk about it. So, and given the recent frameworks that have been coming up around server sent events, I thought it was a good topic to discuss. Any questions?
Have you seen any like real life examples of the server sent events at scale? Because
I have
you
not seen any production applications of it
okay.
personally.
Yeah, I think you kind of pointed it out. One of the challenges, like with if you're using Ruby and Puma, with each one of those connections, it's going to take up a thread.
Right.
And
But my question is why don't WebSockets do the same? Because when I go to wait, that's not what I wanted. I didn't want to do that this time. When I go to my application and I say, you know, call /cable, that initial request is going over HTTP. And it's still using a socket. This socket is, unless there's some deeper magic happening, I believe this is the same socket from the initial request. In which case, what happened? I guess I can try it. I think this actually is like a Puma server on the back end. So like if I open like a bunch of these, I think I've tried this before. I think I can I think that will transmit over all of them. Yeah, three notifications. And I saw all of them come through on the back end too. So
Mm.
I'm pretty sure they have some performance improvements where maybe some things are sent over the same socket, but yeah.
And the
That's my
WebSockets
question.
is bi-directional, right?
WebSockets are
Whereas,
bidirectional, so the client can send messages. That's how you're if you're in Elixir and you're using the live view framework, that relies completely uh, on this protocol being both sides being able to send messages as they wish.
okay, yeah. So I still don't understand. I think we're in the same boat as, why is it why is service end events, which is one way, you would think it would not have the same limitations as WebSockets,
Correct.
but WebSockets
I
seems to
mean,
be more.
I actually more understand the server send event limitation than the other way around. I don't understand
Yeah.
how WebSockets in Ruby. I understand how they're efficient in Elixir, where you have the ability to spin up lots and lots of small processes, but with Ruby, where you just have limited threading, I don't know how that works. So I have some investigation work to do there.
Yeah, I'm definitely interested because I have a limit that I run into with Apex, where because Apex talks and runs directly from the database, one of the ways that they can handle a lot of connections is that the the request comes in, the response, and then disconnect. So it frees up the connections very quickly. Even if there's thousands of requests coming in from different users,
Right.
but it will not work well doing server-side events uh, or directly web sockets. So I need to try to engineer a solution where um, I can still get data from the database that I need, but then use either Node or Elixir or something else that's running as a different service that can do those notifications.
Oh, I think that's what I have a demo on.
All right.
Go
See,
for it.
I pitched it up for you.
All right. You want me to go?
Yeah, it's all yours.
Sure.
Cool. Can everyone see my screen?
Yes.
No, this needs to be updated. So it says Livebook and DB Basic Adventure, also Flame integration. This does have Livebook, but this was really a live view challenge, which I ended up doing. So I was sitting at a bar and someone challenged me to write an Elixir program. Challenges are gifts. So the challenge was make a program to monitor changes to a database and report what's happening in real time. There's another step where I'm going to add a database trigger to do just that. But for now, what's accomplished is that I basically emit events in Postgres. And when I emit events using a notify and listen syntax, it basically puts a message on a channel. And then this is what I'll demo in a second. On the Postgres side, you can just notify and listen, and you can communicate between two database connections, connecting to the same database. But then there's a tool, Postgres, which ships with LiveView. Postgres lets you, it has a notification module, which lets you really easily write your own worker that will be in a gen server and it will listen for these notify events. And that's what I'm about to demo. So I have this project on GitHub. It's pretty simple. Before we get there, there's a few things I want to cover. So a while back, I made this radio little Elixir app. I recently shipped a simpler version of it. I don't know why the syntax isn't showing. But basically it just has a module called radio tower and a module called card radio, and it uses pub/sub to spin up a process. It spawns a process. It has an infinite loop. It uses pub/sub to this start link kind of starts pub/sub, and it allows you to start broadcasting. So this pub/sub.publish is sending out messages on the different stations, and then up here, this car radio, it subscribes to a station and it receives the messages and console logs them. So the thing that it subscribes to in this one is the particular station. I don't want to really cover this. I just want to let you guys know it's there because this isn't the actual meat of the talk and the syntax is quite off. But I knew I had that going into this challenge. And then using sockets to update all sessions when viewing a page in Elixir. So this was hard to figure out from the docs. Basically, when you spin up a live view application, which I can spin up right now, I'll put clear, but I'm running a Phoenix server. And when you spin up a live view application, must log in. Maybe I can't show that right now. I have to figure out my username and password. Maybe I'll register.
Yeah, don't forget it.
Okay. So this particular application has posts as the URL, and you make a new post and you go foo bar and you save, and this is just a page everyone can view. The issue is when you're just scaffolding it for the first time. When that's the case, if you were to open up two tabs and put them side by side, when you update something, if you go like new post, and you go over here, and you do this. Normally when I hit save, it would update on the left here and it would not update on the right. Because I have subscribed and made it so that when I insert to the database, it does publish, and it also in an init phase subscribes to the same channel that it's publishing on. When we hit save, the other session here that's subscribed to the socket also gets the updates. So when foobar comes in, we see it gets updated over here. So that doesn't come out of the box, and the documentation on it isn't that great. I think if Plick is on the call, Joshua, he has actually talked about this in the past. I think he even referenced this same talk, which I watched, which was Chris McCord building the real-time Twitter clone. And in that talk, he covers actually adding the broadcast detail as part of the talk. I, for brevity purposes, went ahead and just showed the commit where I add it into the project. So simply to add that functionality to an Elixir application, a live view application, you would go into the post route, and when it gets mounted, you check if the socket is connected. And if it is, then you subscribe to the blog, which is defined up here. So in live view, the blog is one of the routes that I've scaffolded, and I can show in the create post command, we simply broadcast. In the update command, we simply broadcast. And then this broadcast is a function that we write, and we're basically pattern matching on the OK post, and we're setting up a Phoenix pub sub broadcast on the post channel, and we're sending it the event in the post. So here we do our normal repo.update, which goes in contacts ecto, and then we use this broadcast function to now tell other sockets who are subscribed to the channel that we made an update to posts. So that tells it that it needs to get the updated values. We have this handle info command, which happens and is triggered because of this subscribe. And that will return the post created in the post, which we then run on the update function. That might be in here. The update function might not be in this file, but it basically loads that info onto the page so that we see it in the application. This is also on the show. So this has been added to the show, and this has been added to the post. And basically, this makes it so that the list page works, and also the edit page, when we make a change, we see that the edit is working as well.
So is it broadcasting just because you're logged in as the same user twice, or would all users who are logged in get the same updates?
For this, this page is not behind an authentication, so everyone gets the same
Yeah.
update.
Everyone, okay.
Okay, so that's part one. That's like bare minimum how to level up your live view to have sockets so that all of the state across tabs persists. Now we get into the main challenge, which was how do we listen to database interaction? So some really good blog posts on this. I'm just going to dive in and show you a demo. So this one is set up to already subscribe to a certain event down here. So if I go and log into Postgres, and then if I look at my databases and I connect to this database, okay, so I'm connected to that database. Let's just do this. If I say notify, and just up arrow, notify, and then the name that I'm using is channel, but you could use any name you want. And this parameter is in fact called a channel. So I could say foo, I could say whatever I want. In this case, the Phoenix application is looking for channel in the Postgres setup, and I'm sending a message, oh, hi. So I hit that, and well, first I'll show you the Postgres interface. So PSQL, CAD, and then if I go listen, channel, and semicolon. So now it's told me listen, which means that it worked. And so now if I go back here and I notify and I notify, come on. It's not notifying. It looks like it's got an ampersand here, so I'm just gonna.
And it was like you're commenting.
No, see now it's working, so
go.
it notified, and you see up here the IEX figured it out. So now I'm gonna notify again and again, and we see that Elixir, the worker that's occurring, is finding the message and it's IO inspecting it. I'll show you the code on that in just a minute. So over here, though, nothing has happened. Well, in Postgres, if I now listen again, we get all of them to be received at once. So Elixir is getting the update each one at a time. It keeps getting that update, whereas in PSQL, it seems like it's just every time you run that command, it gives you that info back. Everybody with me so far? Any questions?
It might be a better question for the end, but I'm wondering if this uses. Do you happen to know if this is using the write ahead log in Postgres? Like, is that where these messages are being sent to?
I do not, but that's what I'm. That's one great thing about giving this talk is that I didn't know what the right question was. So write ahead log.
It's also called
Check.
a wall, WAL. You might see some information on that. I thought that was really cool how you're able to get
like it.
previously sent messages.
Yeah, and this is actually kind of like chaining them, which I find interesting. I'm still playing with it. I just got it completed this morning, this functionality here. So that's great. Let's take a look at what it takes to be able to subscribe to the channel. So if I look at the code, basically in the application EX, you just start a worker, and you're going to start that worker in the page itself. So this will be in the note, well, not in the page itself, in the module called notifications, where you're going to be doing this logic. And then you register that worker here in your application as a child of like this entire supervisor. You're going to give it a channel name. And then right here in its simplest form, you start the worker. There's an init. We can clean this up. Clean all this up. And so what we're doing, we're getting the Postgres info from the application environment. We're piping the result into start link, which gets sent as that first parameter. Then we get the PID as a result, and we use Postgres notifications to listen to the PID with the channel, which is the value that we passed in. This is just a random IO inspect to show what's going on. Here's a random PID to show what's going on. And then this listen command is basically going to do all of the pub sub stuff needed in order to listen to those events and receive those events and send them to the handle info callback. If I remove this function completely, I'll get an error in the console asking for handle info with 2 parameters. So I just am going to inspect these variables and then send a no reply and these 2 variables. So right now I'm not doing anything with it. But the idea is once you have these variables that tell you what you need, you then set up a pub sub, and then you broadcast similar to what we were doing here. And you would say like broadcast, what's the caller? Something like that. And that would, your broadcasting to the channel within live view information that then will go and be ingested. Subscribe. I believe it's in the subscribe. Oh, there should be a handle info. Oh, it's here. What am I missing? Yeah, here. Here's the subscribe and then the handle info, and that then triggers update. So hopefully that made sense. I haven't implemented these two things yet. That's next on the to-do. Also, I'm going to be using database triggers. There's a way to monitor update events, delete events, and create events that I've seen, like Postgres events. I'm also going to look if select events works, and then I'm going to look at the WAL that Ryan mentioned today to figure out when those things are triggered, can I emit a broadcast event, a notify event? Since I already have this Postgres notification in Elixir listening to a specific channel, if I can set up database triggers to emit to that channel, I can get any information that I want. Yeah. And then some of this logic, like this handle info, is just a simplified representation of a blog post I was looking at that was around 7 or 8 years old, where they use a poison library, which is a JSON library in Elixir, to really get all the information that they want, and then they kind of update and send it to their application. They have this no reply here. We see they have a broadcast event. They had a to-do application that they were sending it to. So I have a good example of what something built out might look like, but I think I might head it in a little different direction. So simplifying this was a good improvement for me. And John, if you're looking to do something similar, interacting with a database, I think this is a pretty good, pretty simple solution, pretty simple state at present. So it's definitely worth giving a shot at looking at.
Yeah, it definitely gives me some ideas. That kind of matches up with what I've been researching, using a trigger in the database to kick off the notification.
Yeah, let me see if I have that link. I don't think so. But when I pull it back up, I can share it with you, since that's the next thing that I'm doing is that database trigger. Another thing is, like, as I was doing this, I was just documenting like some of the different technologies we're touching, and then like the different tools we're using that we get a lot of them out of the box with live view. So it's been kind of a fun little project. I've seen some examples as I was going through this where presence is a tool that was used to implement, I think it was user permissions. Let's see if I have the link. Yeah, I think I removed the link to it. But if I find that, I'll send that your way as well, John. If that's something you're interested in.
Yeah, certainly.
Cool. And that's it for me. Does anyone have questions before I hand it back to Ryan? Okay.
I thought that was fantastic. I'm now kind of interested in looking more into Postgres notifications or pubs out there. Is yeah, in your example, looked like you were taking the initial message that Postgres sent out, and then you were just kind of you were propagating it to the different gen servers and live views in your app, which is, yeah, that's fantastic.
Yeah, that's exactly what I'm able to do. One thing to consider is if you're triggering notifications on a database, then anyone who has access to that database is able to see those events being emitted by subscribing to that channel. So if that's like a security concern, then it's something to note.
Yeah, I was aware you can
But,
do that with
yeah.
like with replication, which is why I asked about the write ahead log. But yeah, wasn't aware you can really like tap directly into those like I didn't know they actually had a notification system without like setting up triggers or other functions. So thanks for
Awesome.
sharing.
I hear you wanting to work with me on this in the near future. Exciting.
Um,
I'm just curious. I mean, we've said the word a couple of times. I mean, how many of you guys actually use triggers, database triggers, in your applications?
hardly ever.
I don't. Well, I don't. I didn't in my last job, but my first job, technically, we had a database with triggers, but that was all done by one developer, like a solo job. It was not the normal way to
Stop
do
the recording.
things.